everyone to episode 43 in our space shooter DevVenture. So, in our last live stream, we were just about talking with Didn't I create operational layers? Oh, yeah, okay. I didn't share them with the space. Okay. So I was, phew. About to say now, what's going on? I definitely made these threads. Okay. So we were busy with the combat logic in the operational layer. And one of the things we were talking about was how we were going to do a graph to manage chaining, patterns and operation chaining in the patterns, behavior chaining. So I've got Krita over here, and in Krita, remember we did this small little diagram over here to explain firstly what a graph is. Just going to switch to my cursor. Okay, so we explained first what a graph is not, and then we talked about what we could use graphs for when it comes to planning our patterns and behaviors, right? So hopefully that makes sense to you. And I want to actually start. Just give me 1 second. Okay. So I wanted to go into more detail with this, right? So let me just enable my pen tablet so I can do drawings if I have to. But here we go. So we're seeing that first we have to use the seek behavior to get close to the target. And then once we are close enough, then we shoot at the target. And then we fire while in range. And once we are no longer in range, we flee. And then we get to a safe distance where we can no longer shoot at them. Then we seek them until we can start shooting at them. And then we shoot and flee and seek. And we repeat that cycle. Shoot, seek, flee. Shoot, flee, seek. Shoot, flee, seek. Shoot, flee, seek. Right? And then once all of that's done, so once there's no active target left, right? So we've shot the thing to pieces and there's nothing left. Or there's nothing to evade, based on the flee. So we don't have to evade it. So the target's not there, right? Or there's nothing left to shoot because we've shot it. Basically, it's the same thing, but from all the three states, okay? There's no target left to attack. The thing we were attacking is gone, right? And depending on the state we were in, like seek or shoot or flee, it doesn't matter, right? We still have to break out of this pattern. And so we need this state, the break state. And I think we have that. In Godot Engine, there was such a method. I think it was called like stop behavior or something, stop current behavior, something like that. But the point is we had something like that. All right. And so the next step, of course, is to finish off these behaviors, right? So we've got seek works. We have started shoot, and we need to implement flee. And once we have these three, then we can implement this attack pattern. And then we have an attack pattern, right? So I think that would be the next place to go. We've got our diagram, and I think that's a really cool diagram to work according to. So let's open up Godot Engine and see what's going on over there, right? Okay, so we are in Project AstroMiner, and if I go here, so now we've got our steps to do, right? So step 1.1 is design and implement a standard combat pattern. Create basic combat behaviors that AI ships can execute: attack, defend, pursue, evade, patrol. right? And define required parameters and results for each pattern, like inputs and outputs, status completion, status and completion signals. All right, so I want to do a diagram for the standard combat pattern, right? And then I just want to think about how I'm going to do this, because I can't attach too many things to Perplexity, as you know. I'm basically only allowed like 2 or 3 attachments per day. So in this case, I think let's just write it in words with arrows, right? So step 1.1, here is the combat behavior pattern I have in mind. Okay. I will write out connections in. I drew the pattern as a graph, but my attachment limits are quite low. And I am worried you won't be able to interpret the diagram well enough anyway. So I will write out the connections of the graph separately, and you can reconstruct it afterwards. There are 4 states in the graph. 1, seek. 2, shoot. 3, flee. And 4, break. Here are the connections I have in the graph so far. 1 goes to 2. Let's see what I said. Get closer to the target. Get within range of active target. 2 goes to 3. Shoot at active target when in range. And then 3 goes to 1. Flee from active target to avoid oncoming fire, or to avoid return fire and collisions. And then these edges create a loop which can repeat /chain until the active target is destroyed. Or the AI ship or the enemy ship is defeated. Okay. the terminating state in brackets i.e.break has the following edges. 1 to 4. Seek to break is there's no active target to get within the range of, and then 2 goes to 4. No active target to shoot at, and 3 goes to 4 when there's no active target to evade or to flee from. Do you understand this graph? And are there any states or edges I'm missing? Yes, I fully understand the combat behavior graph you described. Here's a clear reconstruction and analysis. It's basically repeating exactly what I told it. And then graph structure and flow. This is a cyclic finite state machine which states for engagement, like seek and shoot, evade, which is flee, and a repeated loop going from 3 back to 1 for ongoing combat, and termination, break for completed or aborted engagement. And then there's a possible missing edge or state. Your graph covers all fundamental transitions for standard AI combat in many games. Potential additional states or edges for future expansion, not strictly required. Edge from 2 to 1, so from shoot going back to seek. For shoot and reseek, if the target moves out of range or needs to reposition between attacks. And then an edge from 1 to 3, so from seek to flee. If the target is too close or dangerous while seeking, flee instead of closing the range. And an edge from any state to itself. For staying in the same state in certain conditions, for example, keep seeking if not yet in the range. Extra states to consider for advanced AI: aim, aim, idle or wait, recover or heal, and patrol. Right? So aim explicitly distinct from shoot. If you want aiming delays or aiming logic, then you need to add this in. And then an idle or wait, do nothing for a while. This could help with more cinematic or strategic behavior. And then you've got recover or heal for self-healing behavior if you add it. And then patrol if you are not actively engaged. And then a summary table of all the current states. If you want to keep things simple for now, your current design is complete and well structured for most circle the target combat AI. Would you like a diagram, a code implementation outline, or decision logic for these transitions next? Or do you want to consider any of the extra possibilities listed above? Thank you for the additional state suggestions, or rather for the additional, well, thank you for the suggestions. Let's just say that. For now, let's get the basics going and then build on it layer by layer. I have seek implemented already, and I need to make states 2 and 3 work before we can establish this behavior pattern correctly. There should be a function to stop the current behavior or pattern in the enemy ship controller /npc behavior manager script files. This means the so-called break state should already exist. What do you think? Your plan and analysis are spot on. Seek is implemented and operational, and you need to implement shoot and flee states next to complete the basic cyclic pattern. The break state or termination is essentially already present through the existing pattern cancellation and deactivation logic in enemy ship controller and NPC behavior manager scripts. Functions like cancel current pattern and pattern related signals, pattern cancel, pattern failed, pattern interrupted, fulfill the so-called break state purpose, and you can stop the current behavior pattern whenever needed. So the next steps and recommendation: focus development on the shoot state. Attach or activate the shooting behavior, trigger attack logic, manage cooldowns, ensure proper handover to flee, and then the flee state, add fleeing or evade behavior logic, like moving away from the target, disengaging, and avoiding danger. And then transitions. Set clear, event-driven transitions between seek, shoot, flee, and break, using pattern assignment and completion failure signals already present. This keeps your system modular and ready for expansion, while also using the architecture and interfaces you've already implemented. When you are ready, I can help outline the shooting and fleeing behavior code to provide the logic flow for wiring these transitions up in your tactical or operational layers. All right, so yeah, we've got our angle of attack or our itinerary, what do you want to call it? Our plan. Whatever it is, the next steps, right? So let's get to work on those. So let's say this. Let's start working on the shoot behavior first. You should have the existing logic for the shoot behavior, for the behavior underscore shoot.gd file. So let's start there and build on it using the behavior graph I shared with you and the general idea I want executed. We can use the helper functions like line of sight in brackets, like so, like line of sight, etc., to assist with checking and making shots so the enemy ships look and act smarter. Wow, it's never really hanged for this long before. That's interesting. While it's busy, let's go back to Godot engine and just check, what does behavior shoot actually contain? It's got has line of sight, aim at target, aim at position, trigger shot, fire single shot, set target position, or complete shooting. So it has all of these like helper functions enabled already or implemented already. We just need to be able to use them, right? So the NPC behavior manager should be able to call these things, and it should be able to say, okay, well, NPC behavior manager, get the shoot nodes, has line of sight method, and activate it, and then use that result to trigger a shot or to fire a single shot or something, right? So we've got that, and it's finished. It's finished now. So here, great. Here's how you can build on behavior shoot so that it fits cleanly into your behavior pattern graph. This outline leverages what you already have and focuses on stateful, in quotes, stateful transitions and AI feedback, making the shoot behavior robust and modular. Okay? So the structure goals, there needs to be activation, shooting loop, transition handling, and that's it. Okay, so it should activate and receive the target information and shooting parameters from the tactical layer. So the tactical layer needs to tell the particular enemy ship, hey, you, enemy 5, shoot at the player. Or, hey, you, enemy 5, shoot at mining vessel number 3. You know? And then it goes, hey, awesome, let's get that position and start seeking him. And then once we've sought him out, we get close enough, it's in the range. Now we start doing things like, do we, are we aiming at him? Once we are aiming at him, do we have line of sight? Once we identify we have line of sight, fire a single shot. And all those kind of things. So there should also be a thing of determine. For now, it's fine, but excuse me. But eventually, we want to be able to say things like gauge velocity. Because you want to see from gauging the velocity. I drew over it already, but yeah, like this. So if this is the enemy and that's the mining vessel, and the mining vessel is moving at 25, and the bullet fires at 50, we want to make sure that we at least aim half the distance ahead of the mining vessel. So he's going 25, this is going twice as fast. We only have to aim half of the distance that this thing was covering, and the projectile should hit. Right? Roughly speaking. I might be wrong. We'd have to do the full calculation to be sure. But you get my point, right? That we can do smart things like intercept trajectories and shoot where he's going to be, not where he currently is. That kind of stuff. So for now, it's fine. We'll just get it working, and then we can make it smarter once it works. So that's activation. And then the shooting loop, right? So continuously tries to make a shot. Continuously attempts to shoot if the target exists and is within the range, and there is a clear line of sight using your helper function, and then the gun system is ready, right? So there's a projectile ready to be fired, i.e. the shot cooldown has finished, and can shoot, the boolean can shoot is true, right? And if we are currently aiming at the target and there's a clear line of sight and the target exists, right? So the target does actually exist. So if we say shoot at mining vessel 3, but mining vessel 3 is already defeated, there's no point, right? So I think we've covered that. Then transition handling emits a so-called completed signal if the target becomes invalid, like it's destroyed or out of range. So the tactical or strategic layer can break or move on. And then there's a shooting cycle that is completed, right? So it's complete. It could add burst or clip-based logic, right? Excuse me. So maybe you've got clips, like magazines or whatever, you know, rounds of projectiles that you can fire. So you can only shoot 50 projectiles, and then you need to swap out the ammo belt or the ammo crate or the battery or the gas canister, whatever you're using to fuel your projectiles, you know, to fuel your projectile supply. And the other way, of course, is burst fire, right? So shoot 5 shots and then start fleeing, regardless of whether you are too close or if the enemy is shooting back or anything. Just fire 5 shots and then get out of there. You could add that in too. That's what they mean by burst. Excuse me. That's what they mean by burst logic. So you go in, go doof, 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 and then fly away. And then you come back later and you start firing again. 1, 2, 3, 4, 5, and you fly away. Like that. And then emits a failed signal if the target is missing repeatedly, or if a fatal error occurs, right? And then optionally emits a progress or status signal for more advanced AI monitoring. So here is the clean pseudocode. Just want to adjust my camera so that you don't see me peeking out of the camera every time. I think that works better. So yeah, apologies for that. Right, then it emits a progress or status signal for more advanced AI monitoring. And then here's clean pseudocode and a refactor plan based on your needs. Pseudocode? Why not just give me proper code? It's in text. Anyway, so yeah. That's the pseudocode it's provided. And then here's the key points. Things like transitions, configurable, line of sight or range, and then an easy plugin, right? So if the target is lost or out of range, the behavior halts and notifies the tactical layer to break. It's configurable, so it accepts parameters for range, burst, and continuous fire. There's a line of sight or range, so automatic checks to look smart, and easy plugin. All state transitions are handled via behavior completed signal. The next suggestions: start implementing or testing the shoot with this logic in your NPC behavior manager as a pattern, plugged into your graph. And once this is confirmed working, use a similar modular approach for flee. Are you ready for a GD script implementation or integration guidance with your tactical layer? So I want to ask this question. Is this pseudocode or actual code? Can I copy it and paste it? And is it safe to do so? If I can't, then I'm going to have to look through this and just use my discretion as I transfer the information across, right? Because it's saying variable parameters of type dictionary looks okay, but let's just do that confirmation check. Is the pseudocode you provided usable. You wrote it as plain text, but it looks like valid GD script code. Is it safe to copy and paste this code into my code editor, or should I use this as a reference and make the changes manually? I think they changed their operation procedure. So now the free version of Perplexity takes longer to think. Because look how long it's working. It never used to take this long. And it also presents that little banner at the bottom saying, oh, you've used up your daily limit of whatever searching or whatever thing. So I think it's actually taking longer on purpose to frustrate me and you into paying for the pro version. Pseudocode I provided is written in valid GDScript style and is designed to be mostly copy-paste ready for your behavior shoot file. However, before directly copying and pasting, please note that the structure and syntax are correct for Godel 4.x GDScript. Some variable names such as gun pirate, target node, or signal parameter names should match your project's conventions or node names, so double check these for your specific scene structure. And then the code expects the existence of certain helper functions like has line of sight to target and trigger shot, which you already have or will implement. The parameter dictionary parameter dictionary keys like continuous, range, etc. should be set by your tactical layer when activating the behavior. The recommended approach is the following. You may copy and paste this code into your code editor, and then after pasting, review and adjust. So the node paths and names for your exact scene setup needs to be reviewed and adjusted, and then any signals, variable types, or expected fields that differ in your own behavior shoot script, that also needs to be reviewed and adjusted. And then integration points for activation and completion with the tactical layer needs to be reviewed and adjusted. So test incrementally to confirm everything works as intended and address any minor issues or typos that may arise during integration. So in short, you should be able to copy paste and then fine tune. So let me know if you'd like me to help adapt this further for your current files or scene setup. Okay, so I think we have some time. Let's go through this and make sure it works before we paste it over. Okay. So it extends a node. The class name is type behavior shoot, which is the same as it was. We've got the signal behavior completed. Takes in who completed the signal as an integer, what behavior was completed as a string, and the status of that completion as a string. And then any additional data as a dictionary. And then it's got a variable for the enemy ship. So who's doing the shooting? And then a gun system, right? So what is doing the shooting? So who's doing the shooting and with what are they shooting? And then the target node, what are they shooting at? And then is active continuous shooting, parameters, and then new new patterns like shots remaining, shot interval, shot timer, maximum range, and then we move on to the functions, right? So things like activate and deactivate, and then the process function, which does all the heavy lifting and has line of sight to target and trigger shot. And then we've got complete shooting, but we don't have shoot once, and we don't have some of the others. So we can't copy and paste over all the current code. It's more like we have to copy and paste over the existing code where it is relevant. All right, so let's do this comparison first. Let's open up Godot Engine and put this up here next to that. So we've got an enemy ship called type enemy ship. That's fine. We've got gun system, which is a node. And then we've got target node, which is a node 3D. That's fine. Is active. Yep. Boolean, that's false. Parameters as a dictionary, we've got that one too. Continuous shooting as a boolean, it's true. And then we have some new patterns to implement. So let's add these in. Shall we? We'll make a comment here. New patterns. Are these patterns? No, we'll just say new variables, because they're not patterns, they are variables. Okay, so a variable called shots remaining is of type integer, and the value is 1. You can make a comment here and say for burst or clip support. Okay. And then we've got another variable called shot interval. And that one is a float, which is a 0.5 value. And this is the seconds between shots. And then we've got a variable shot time, also a float, also 0.0. And then we've got variable maximum range is of type float, and it's currently set to 2500 hash, or we get from parameters. Okay. And then we can just move these all to a designated column so that it's nice and tidy. That one goes there. $15, $16. Then this one also. Okay, so we've got that implemented. And then just smoosh those together into a block. And now in the activate function, let's just confirm this is all working fine. Takes in an enemy ship ID, which is of type integer, behavior parameters as a dictionary, and then enemy ship get parent dot get parent as type enemy ship. Gun system is enemy ship. So there's this thing to save if the enemy ship cannot be found. So this is just a safety block. We don't need to panic. That is fine. We have it. It's okay. Then the gun system is an enemy ship dot get node or null gun pirate. And then again, if the gun system is not defined properly, we have that safety block implemented too. Then we've got parameters, which is behavior parameters. Is active is true. Continuous shooting parameters dot get continuous, comma true. And then if parameters has a target node path, then target node is enemy ship dot get node. Target node is parameters dot get target node, comma null. Okay, so what I'm going to do here is I'm going to take my current script and I'm going to tell Perplexity to just give me a second, I'm trying to think. I'll tell Perplexity to rewrite this pseudocode to be actual code. Otherwise, what I can do instead is I can implement these missing steps from the pseudocode into my code directly and manually. The problem with that, of course, is it's going to take longer for me to think it through and get it right, and I'll probably take up the rest of the session just doing that. So it's a trade-off, right? But maybe I should do that, because otherwise I'm not benefiting if Perplexity is just doing all the heavy lifting for me. So let's go. Let's do this. Here is my current implementation of the activate function in behavior shoot.gd. Please check this against the pseudocode you provided and make sure I'm not missing anything. Your activate function is well aligned with the pseudocode provided and covers the key initialization steps for the shoot behavior. Here's a direct breakdown comparing your implementation and suggested approach. Implementation 2, the suggested approach. Additional or optional improvements. It checks for a valid enemy ship parent, gets the gun node, stores behavior parameters, marks as active, extracts continuous shooting parameter, sets the target node based on parameter path or direct reference, and prints the activation debug information. Consider adding the following, but these are optional and for feature expansion. Extract or initialize values for the number of shots or burst, shot timing, and maximum shooting range, and then initialize timers, counters, etc. if required by your full shooting logic. So reset the shot timer. The handle fallback or defaults if target isn't supplied or parameters are missing. You could emit a failed signal for robust feedback. And then here's the example extended version. If you want to support expansion, you could use this. Your current function is correct for the core behavior, and you are not missing anything critical for standard shooting logic. Only add expand parameters and error handling if you plan to support more features. Let me know if or when you want to expand this for burst, custom range, or other upgrades. Okay? Now let's go through this and just check. So that's the start of the thing. Get the parent as type enemy ship. If it's not an enemy ship, push an error, type behavior shoot, could not find enemy ship. Behavior completed.emit, enemy ship ID, shoot failed, and the reason is no enemy ship. And then you call return to obviously to break out of the function. And then you've got a gun system, which is enemy ship.get node or null gun pirate. And then if not gun system, push error, type behavior shoot, could not find gun system. And then behavior complete dot emit, enemy ship ID, shoot failed, reason no gun system, return. Same thing, right? Then parameters, behavior parameters, is active is true, continuous shooting is parameters dot get continuous true, which is over there. And then down here, if parameters dot has target node path, target node is enemy ship dot get node parameters target node path. Else if parameters dot has a target node, set the target node to parameters at target node. Else push an error, behavior complete dot emit is active is false, and return. So we need to add in this else statement, and then shot timer and print. So we need to do this and that. Okay, so let's do this. Else push error, behavior underscore shoot, no target specified. Then we say behavior completed dot emit with the enemy ship ID and shoot, and then failed and the reason was that there was no target. So that's the one thing. Then we need to say is active. We'll set that to false and call return. Okay, so that's done. Now I can set these to be into column 50. So there and there are the same, and there that's the same. So we'll move all these across to 50, 21, 21, 19. Okay, and then we've got the, before the print statement, we need to set the shot timer. So let's do that. We'll say shot timer. I'm sure I must have written this wrong, wasn't I? Shot timer. Okay. Shot timer equals 0.0. We set it to 0, and then we print out this thing. Okay. Your current function is correct for the core behavior, and you are not missing anything critical for standard shooting logic. Only add or expand parameters and error handling if you plan to support more features. Let me know if you if or when you next want to expand this for burst, custom range, or other upgrades. Okay, so let's go back up to this. So that was the activate process. Now we need to look at the deactivate process, which is this. Is active is false, and print shoot behavior deactivated. So that's fine. And then in the process function, here we go. Okay. And I see, so has line of sight to target is there. So process is supposed to be a lot bigger than it currently is, apparently. So if not is active or not enemy ship or not gun system or not target node. So here, or not target node. So we add that in, then return. So if any of these are true, right? So if it isn't active, or if it isn't an enemy ship, or if there is no gun system, or if there's no target ship, target node, then return out of the process. Okay? And then transition logic for no target. If the target node is null, so we add that in here. So we'll say if target node is null or not is instance valid target node, then complete shooting with failed and a dictionary with reason being the target was lost, and then return. Okay, and then so this is logic for transition logic for no target. And now we have another one here saying check if within range, create a variable to target is target node dot global position minus the enemy ship dot global position. So what we're doing here is we're saying get the direction to the target, right? So where are we? I think it's the distance to the target. Yeah, because they're checking within range. How far away is the target? And then if two targets length is greater than the maximum range, then obviously break, because we're not able to shoot, it's out of range. So that's what we're doing here. So now we check if two target dot length is greater than the maximum range, then we say complete shooting, that the shooting failed for the reason that it was out of range, right? And then we say return, because we're not carrying on with the shot. Okay, and now we check the line of sight. Check line of sight. If not has, or rather underscore has line of sight to target, then return. And we make a comment here saying that this could add, we could add a retry logic or a wait here, but for now it's just going to return. So if it doesn't have line of sight, and then here is ready to shoot. If target and has line of sight, shot timer plus equals delta. If shot timer greater than shot interval, then trigger the shot. What does trigger shot do? If gun system and gun system has method on trigger, on shot trigger, then gun system dot on shot trigger. So trigger the shot and then set the shot timer to 0, shots remaining minus equals 1, and then if shots remaining is less than or equal to 0 and there's no continuous shooting, then complete shooting, completed, and return. Okay, so this part is quite a basic implementation compared to this. So if the target node exists and there's a clean line of sight to that, then aim at the target. If continuous shooting, then trigger the shot. And then if we have a target position but there's no specific node, shoot at that position. So else if parameters.has target position, aim at position parameters target position, and if continuous shooting, then trigger the shot. Has line of sight to target as previously implemented. Trigger the shot. Here. If gun system and gun system has method on shot trigger, then gun system dot on shot trigger. And complete shooting here. Behavior completed dot emit enemy ship ID shoot status data set is active to false. So it's missing some of the functions, but I think it's because they are supposed to be as they are with no changes. But anyway, I think this is a good place to stop for now, because we kind of hit the hour anyway. But thank you so much for your time and your attention. A big shout out to Cubes. Thank you so much for your support. Everybody feel free to go to coffee.com/mtkdev to support the channel. Or you could simply subscribe and like this video and share the link with as many people as you can. That also supports the channel more than you realize. And yeah, I'll see you in